Today we are going to introduce the definition of a derivative. So you will recall from advanced functions this picture of a curve right here, and I'm going to take a look at this one, and hopefully you remember from advanced functions that this is a secant line, right? A line between 2 points basically, and this red line right here is an example of a tangent line, a line touching the curve at exactly 1 point. And in advanced functions, we talked about this idea of this being some point P with the coordinates x comma y or x comma f at x. And then some distance, we're going to now call it h away. We have this point Q, and its coordinates would then be its x coordinate is x plus h, its y coordinate is f at x plus h. Okay, and the idea being the slope of that secant line or that green line is simply the rise over the run, which simplifies to this. Now, if you recall, this was also called the average rate of change, right? Or the slope of the secant line, just the slope of that green line. But as we move as we move the point Q closer and closer to the point P, this value of h becomes smaller and smaller, and you'll recall that we did it as close as 0.001 on either side, and what happens is this secant line becomes an approximation of the slope of the tangent line. Okay, so in other words, as the distance between P and Q gets smaller and smaller, this value of h gets smaller and smaller and approaches 0. And so I hope that you can see then that the slope of the tangent line, which is really the IROC, the same as the IROC, is really just the limit as h approaches 0 of that quotient. And so this expression right here represents the slope of the tangent line, also known as the instantaneous rate of change, and actually also noted as the derivative of a function f of x. So now we're just going to pause the video for a minute and we're going to write down this very, very important definition. Okay, so the derivative of a function f of x, denoted by, we read this as f prime of x, is defined as the limit as h approaches 0 of f of x plus h minus f of x all over h. And today we're going to look at finding the derivative of a bunch of different functions. Again, this means the same thing as finding the slope of the tangent line and finding the instantaneous rate of change. And we'll talk more about that after we've done the first question. All right, here we go. So first what we're going to do is we're going to find the derivative of this quadratic function right here. And one other thing I want you to definitely pay attention to is this is actually called finding the derivative from first principles. And that will make more sense to you as we move into the next unit. Okay, so our derivative, f prime of x, is the limit as h approaches 0 of f of x plus h minus f of x all over h. And you need to write that statement out every single time you do a practice question to make sure you understand it. So now the question is, what's f of x plus h? Okay, so pause the video for a minute and see if you can figure out if this is f of x right here, what's f of x plus h? Okay, so hopefully you can see that this is f of x plus h minus this is our f of x. Now you should notice if you actually tried to solve this limit by substitution right now, you would actually get 0 on the top and 0 on the bottom. So this is a 0 over 0 situation, an indeterminate form, and so we need to do some simplifying and expanding on the top, and hopefully some good things will happen. So go ahead, pause the video, and expand and simplify the entire top. Okay, this is what I got on the top. Double check your work, make sure you got the same thing. And now note a couple key things. X squared minus x squared cancels out. We have an x minus an x cancels out. And we have a negative 6 plus a 6 that cancels out. So let's see what we have left over. You agree? Okay, and again, if we still substitute in h as 0, we would definitely get 0 out of 0, but hopefully you can see that in the entire numerator, you can actually factor out an h. So it looks like this. We can factor out an h, and then we're left with 2x plus h plus 1 all over h. Again, it's that trusty tool of factoring. And note now the h's cancel out. That's what we call our problem piece, right? That h in the denominator is really our problem piece that needs to be canceled out. And we are now able to take that limit by substitution. And we end up with 2x plus 0 plus 1 by substitution. And so we get a derivative of 2x plus 1. Okay, now just to conclude, therefore, then, if the function is x squared plus x minus 6, then we found out that the derivative is 2x plus 1. Now, one thing that I need you to notice is that the derivative is a function, right? This is a function. So this is the function that would give you the slope of the tangent line or the average rate of change at any value of x that you put in there. So it's a general formula for the slope of the tangent line or the instantaneous rate of change at whatever x value you want for this original curve up here. Okay, but today's goal really is just to practice this process. Okay, this process of finding a derivative is called differentiation. Finding a derivative in this way, as I said before, is called first principles. And this notation right here, dy over dx, the derivative of y with respect to x, is another notation that you will see and we'll talk more about in the next unit. So for now, our goal is to master this process of finding the derivative, which you'll notice uses all of your algebraic limits that you previously learned. Let's try another one. Okay, here we go, a radical function. Hopefully you can think about what tool you're going to be using here as it is. Start by writing out your statement, the derivative equals, you go ahead and write it in and pause the video and then restart. Okay, how did you do? Again, notice if you plugged in 0 right away, you would get 0 over 0. This is in an indeterminate form. And what's your strategy here? You see a radical, so you are going to multiply by the conjugate. So the conjugate is going to be x plus h minus 5 plus x minus 5. And of course, you have to multiply both the top and the bottom by that. And then you're going to use your skills from algebraic limits to make sure that you can simplify that. Remember the rule that you're not going to do anything to the bottom, you're just going to leave it the way it is, and you're going to FOIL out the top if you like, or expand and simplify it. Let's see if you can get this one to work out on your own. So pause the video and see if you can do some simplifying on your own. Okay, be careful of your form, be careful of your brackets. Hopefully you can see what I did there. And now note, as we simplify the top, the x's cancel. We have a minus 5. This becomes a plus 5, so those cancel. And we are simply left with an h on the top and our entire bottom. And again, hopefully you can see this means that our problem piece, that h on the bottom, is going to cancel out. And we are simply left with taking the limit as h approaches 0 of 1 over x plus h minus 5 plus x minus 5. And go ahead and take that limit by substitution now. Okay, and so this is what you should have gotten at the bottom here. Therefore, the derivative is 1 over 2 root x minus 5. Okay, let's try one more. Now this one gets a little bit complicated, so I want you to try this one as much as you can on your own, and then come back and take a look and freeze the video and take a look at my solutions. This one does get pretty long. You'll notice it's almost an entire page just to work on this one question. Okay, so here we have our definition of our derivative. Here I've put in our functions. And now hopefully you can see we got fractions within fractions. So our first goal is going to be to simplify. We're going to want to make this a common denominator. So go ahead and do that. Okay, and here's my common denominator. Note, if you have an extra 2 in here, it's not going to be a big deal. It's just going to be harder to see where I'm going with this. And of course, now I've moved my divide h over here, and I'll ultimately just change that to multiply by 1 over h. So now I want you to see the top as a difference of cubes, right? This is a factoring, and I want you to go ahead and factor the top and see if any good things happen. Okay, here's what I got for my difference of cubes on the top. And before we bother expanding this yucky thing over here, I want you to take a look at this bracket over here. And if I was to expand and simplify that, hopefully you can see that the x's cancel out and you ultimately just end up with a negative h in that position right there. Okay, which is of course our problem piece, which is going to cancel out with our h over here. Okay, so let's see if we can write out the rest of this solution and see what happens. Okay, so here, like we said, our h's cancel. This limit is no longer in determinate form. We no longer get 0 over 0. And so now we are simply taking the limit as h approaches 0. We have a negative 1 here. Don't lose that negative 1 of this. And so see how we never really needed to expand all of this? We're now just going to take our limit. All of our h's are going to go to 0 and see if you can get the right answer. Okay, so pause the video and take that limit by substitution. Okay, there you see my solution. And if we do then simplify that just a little bit further, we end up with 4 there. So we end up with negative 3 on the top and a 2x to the 4 on the bottom. Therefore, the derivative function is negative 3 over 2x to the 4. Okay, so this is going to require some practice. There should be questions within your package that you printed for you to work on here. Do your best with those questions. Do as many of those as you can.